well. I'm Heather Kolich. I am the Agriculture and Natural Resources Agent and the County Extension Coordinator for Forsyth County. And I'm glad to have you here with us today. Hopefully you've learned something from the other classes in this series and will join us next week for our next one as well. Today we're going to talk about urban tree disorders, and they come in basically two flavors, biotic and abiotic. Let's see if I can get my slides going. So I've got some objectives for you. By the end of this class, I am hoping that you will be able to differentiate between symptoms and signs, state two common causes of biotic disorders, and state two common causes of abiotic disorders. So as part of our landscapes, trees have value that we want to protect. And when our trees have a problem, the first thing we've got to do before we can treat that problem is figure out what is causing that problem. So what we see, what do we see when we're looking at things? What might we see that makes us think there's something wrong with that tree? I got some clues up here. Most often we are going to notice abnormal looking leaves. Leaves are, once the flowers fade, and they're only there for a couple of weeks or so, leaves tend to be the most visible thing, the most eye-catching thing on a tree. So we're going to look at leaves, and when something's wrong with the leaf, that's what we're going to notice more often. But there can also be symptoms on branches, on stems, other parts of the tree, and also in the root system that we're not going to see because that's underground. But all of these can have symptoms of disorders. We need to look at all parts of a tree for signs of pests and pathogens to diagnose what's wrong, diagnose biological issues. And to diagnose those non-biological issues, the abiotic disorders, we've got to look at the environment all around the tree and maybe even the history of what's been going on with that tree. So symptoms are abnormal changes that indicate problems with a plant. Signs are clues about what's causing those symptoms. Signs are evidence of a pathogen, a pest, or an abiotic issue that may be causing the problem that's causing the symptoms that we see. So if we see leaf spots or holes in a plant, we might look for fungal spores or hyphae. If we see skeletonized leaves, we might look for clues for signs of caterpillars, or what do we have here? Those are Japanese beetles. Poop, frass, yep, that's what all this little black spots is frass or poop from the bugs, because they're eating those leaves so fast, they're pooping it right back out. And this little critter, this colorful little guy, is a leafhopper that also can cause problems with our plants. So let's take a look at some symptoms. This is discoloration in leaves. So if we're going from the top, I don't know if you can see my mouse or not, but we have some discoloration in leaves at the top. The second photo going clockwise, we've got some bare branches on a tree that looks like it should be all leafed out. Down here on the bottom right, we've got some abnormal growth changes in a leaf. In the middle of the bottom, we have these very colorful leaf spots. And then back right over the UGA, we've got some weird stuff going on with this tree. It looks like we've got some webs and some defoliation going on there. So all those are symptoms, the changes that we see. And then we can look for signs that might tell us what's going on. So signs are going to be evidence of the pathogen that's causing that problem. Here are some more signs. We've got some fungal hyphae and spores on a leaf petiole. Over to the right, we've got mold or mildew on a leaf, and we can also see that discoloration around there. So the discoloration is a symptom. The mold is a sign. Down below that, we've got skeletonized leaves, a symptom, and then a sign of what's causing it, the Japanese beetle. Over to the bottom, we've got some galls, some abnormal leaf formations, and then we can see, as a sign, larval insects coming out of those galls. Over here on the left, what does that look like? That is drought. That would be a definite sign of drought, all of this cracked soil and dry soil. And then right in the middle, we've got these frass tubes, these extensions coming out of the bark of a tree. And those are signs that we've got boring beetles in there, because these are the frass tubes that they push out as they bore into that bark. So let's talk about the difference between biotic and abiotic. Biotic disorders have biological causes like disease. Disease breaks down into three typical ones: fungal diseases, diseases that come from a fungus agent, bacterial diseases, or viral diseases. We can also have insect pests and wildlife pests, and all of those are living, so they're biotic issues. Abiotic issues typically are not a living agent, but they are something that comes from physical causes like nutrient deficiencies, nutrient issues. It could even be nutrient excesses, weather, soil issues, environmental stresses, a physical injury. And the last one is what I call operator error. Those are things that humans visit upon a plant that causes it to have disorders. So biotic orders have, basically there are three things that can cause them. And when all of them come together, that's when we get the disease area. So the three things are the susceptible host, a plant, in this case, that is going to be susceptible to a pathogen. The pathogen is present in the environment along with that susceptible host. And then we need to have a conducive environment to allowing that pathogen to proliferate. So when these three things come together, we get disease. So if we look at fungal diseases, the biotic disorders, 80% of the plant disorders, the plant diseases that we see are going to be fungal. The fungus is spread by spores. Spores are very, very hardy and can live for a long time in the soil or in leaf litter, and they will come back up, start reproducing, and start growing again when conditions are favorable for that. Typically, that's going to be a warm, wet, or shady environment. A fungal disorder will often present as a round spot on a leaf. That's where the fungus lands. That fungal spore will land on a leaf, and under those favorable conditions of warm, wet, and shady, will start to germinate. And so it will start decaying the leaf tissue around that spore, which is typically round. So we'll see something like shot hole, or this is rust fungus that's growing in a round presentation. We might also see them as powdery mildew, the white powder that covers a leaf. And fungus can also affect roots. So prolonged leaf wetness and particular temperatures are going to promote fungal growth. Some trees and plant cultivars are more resistant to particular fungal diseases. So in the examples of the crepe myrtles that have the Indian names are going to be more resistant to this powdery mildew than some of the other varieties are. Cultural practices can be very effective in reducing fungal disease issues. Things like avoiding overhead watering. That leaf wetness, we want to keep those leaves as dry as possible. So water them at the root zone, which is where they need the water, instead of hitting them with a sprinkler. Provide proper spacing so that the air can circulate around the leaves and help dry them out. Prune the trees to let sunlight and airflow enter through the canopy. That also helps dry the morning dew and rainwater off of those leaves, which is going to cut down on the germination and proliferation of fungal issues. Sanitation issues are going to be important too. I mentioned that the spores can linger and stay viable in leaf litter and in the soil. So clean up all of those dropped leaves, all of the dropped fruit or blossoms, clean those out from around there, and you're going to eliminate some of those fungal recurrence issues. And also, if the spores are down in the soil, adding 2 to 4 inches of mulch is going to help keep the spores from splashing back up onto new leaves when the rain falls. So that'll help, the mulch will hold them down. It also reduces a lot of stress issues as well. For recurrent issues, if you know that you've got a susceptible plant, or if you know that you've had fungal issues in the past, a preventive fungicide treatment before the weather conditions become favorable to fungus outbreaks can help mitigate it. But fungicides don't actually kill fungus. They just disrupt at different areas the spore germination. And they only last for about a week, anywhere from 7 to 21 days. And then they wear off and the spores are free to start germinating again. So in order to control a fungal disease, once it starts breaking out, you have to retreat that plant every 7 to 21 days, depending on what kind of treatment that you're using. So prevention is going to be better than trying to treat it, because treatment is an ongoing thing for as long as those weather conditions are favorable to that fungus outbreak. Fungal diseases don't usually kill trees. There are a couple of exceptions. Fungal spores germinate and the fungus will grow when those conditions are right. But as soon as the conditions change and aren't favorable anymore, then the fungus issues typically go away. Our season for fungus issues is spring through fall, or spring and fall here in Georgia. In the summer when it's hot or dry, when we have drought conditions, we're not going to have fungal issues. The damaged leaves that drop off in the fall they were going to drop off anyway if we have deciduous trees. So fungus doesn't typically damage the buds that are going to sprout out next year when spring comes around. So losing those damaged leaves in the fall is not going to affect the tree at all. It has typically started its slow down growth. Those leaves aren't going to be necessary for photosynthesis over the winter. So that's not going to be damaged. But again, cleaning up those dropped leaves that are harboring the fungal spores is going to be important for preventing an outbreak the next time around. When problems arrive with fungal issues, it's when they happen at the beginning of the season and cause the plant to defoliate. That is the natural response of some plants, that when they get that fungal disorder, they're just going to drop their leaves. What happens then is they will try and push out some new leaves. So that's going to start taking out carbohydrate stores in the roots and weaken that plant over time when they can't, when they continue using up the stores of carbohydrates without being able to replenish them through a good season of photosynthesis. That's when they start weakening and can decline over time. There are a few fungal issues that will kill trees. Fungus that attacks the roots, such as Phytophthora root rot or crown rot. This is a maple tree that is suffering from that issue. And this is very visible. We don't usually see root rot issues that are this visible because they're under the soil. So we really can't see that. But this has become very pronounced and it's visible. Usually root rot symptoms we're going to see as dieback at the top of the tree because the roots are not able to push water up to the top of the tree when they're weakened. So we'll see some defoliation or some dieback at the top of the tree. And fungicide, you really can't treat root rots with a fungicide because it's difficult to get the fungicide onto the roots without actually having to expose them. And if you expose them and remove the soil, then you're going to be damaging the roots anyway. Also, fungicides will not stop the soil wetness that helps, that underlying condition that caused the problem in the first place is usually soil wetness, and a fungicide can't stop that underlying cause. On the right here, we have Ceridium canker in a Leland cypress. This is something that actually causes the vascular tissues to be clogged up so that can't move moisture out to the tips of the trees. So we have random branch dieback throughout the tree. This is something that cannot effectively be treated with a fungicide. So that will eventually kill the tree. There are a couple of other fungal issues with Leland cypress that it's in a tree that large, it's not a practical, you really can't get out there and treat a tree that large with fungicide every 7 to 21 days. So there's a suite of fungus issues that will eventually kill the Leland cypress. Bacterial disease, this is a crown gall that was caused by some kind of bacterial issue. Bacteria can affect the leaves, the flowers, the stems, the trunk, and they're spread by insects, tools, roots that come in contact with trees that are the roots of trees that are already infected. We may see them as a leaf blotch or a leaf scorch, or as things like this crown gall. Preventing the crown galls, really, you've got to start with healthy tree material, healthy plants that are not infected. Sanitation and planting resistant varieties are also going to be important for that. Bacterial disease can be spread so when you see a bacterial disease as opposed to a fungal disease as a leaf spot, these leaf spots are going to be blotchy, irregular in shape because they tend to move along the vascular tissue. So instead of seeing the discrete round holes that you would see with the fungal spores, you're going to see a spread, and they might look kind of wet as well. This fire blight is a very distinctive symptom of fire blight, or is that crooked over end of the stem along with the scorched leaves. The fire blight is actually spread by the bees as they are pollinating trees. It's quite common in apple trees and pear trees. And while the bees are pollinating them, they're actually spreading the bacterium through the blossoms. And then it enters in through the end of the stem and can move back through the stem. Pruning is one of the ways to control that. You can also use some copper type treatments to help control it, but it's very important that when the tree is blooming, you're not doing any kind of pesticide treatments, because fungicides and bactericides will also kill your pollinators. And then there are viral diseases, and these are also they can be spread by insect feeding, they can be spread through the roots. These affect all parts of the plant. They are systemic. And you might see these patterns of chlorosis or leaf yellowing in there. A lot of variegated plants actually started from viral issues. Purchasing certified clean plants is step one for preventing introducing viral diseases into your landscape. The next thing is keeping that that landscape free from the weeds that provide hiding places for the insects that spread the viral diseases. Insects like thrips, sharpshooters, and mites. They pierce the plant cuticle and suck juices out of the plant. And then that's how they move the virus from plant to plant. So they'll pick it up from one plant, move to another plant. Well, now, that they've picked up the virus, they're infected with the virus. It's not going to affect them, but they're definitely carriers of it. And as soon as they pierce that plant cuticle and start sucking the juices out, they have pushed that virus into the next plant. When that virus enters the leaf matter, it's going to start reproducing, and it's going to spread through all parts of the plant. So once you've got an infected plant, you can't treat it. There are no treatments, no cures for viruses, and it becomes a source of contamination or virus disease spread to other plants in the environment. So the best thing to do is pull that out and destroy it, and go back in with a plant that's maybe in a different kind of family, because rosette disease is spread by mites, and as soon as that plant you can't prevent it, because you can't prevent the mite from biting the plant. Even if you treat the plant to kill the mite, it's got to bite the plant to get the pesticide. So getting rid of the plant is the best way to protect the other plants around the environment. So galls are abnormal tissue growth on the leaves, and sometimes they can be on stems as well. You can also see them in larger branches. They are very interesting and can be quite beautiful. Some galls are fungal. So the galls that you see on azalea leaves sometimes that cause them to get all fat, those are fungal, but others are caused by insects. So as she lays her eggs on a leaf, the insect is going to secrete a chemical that actually causes the leaf tissue to change how it's growing. Instead of growing smooth and flat like it normally does, it's actually going to grow around the eggs and create a protective pocket for them. So it kind of incubates and keeps the eggs safe while the insect goes off and does whatever she does. They can be unsightly, but they rarely harm the trees. The leaf continues to function in its normal processes of photosynthesis, respiration, and transpiration. And when those eggs hatch, the larvae will just kind of chew a hole and exit the gall. The leaf doesn't recover, but as leaves do, it drops off, and the new ones that come out will not be affected by that. So let's look at some abiotic disorders. They can also look very much like some of the biotic disorders that we just looked at. So what does this is a redbud tree. What do you think is happening with this leaf? It kind of looks like the discoloration that was caused by the virus, right? But this is actually herbicide damage. The diagnostics signs of wind-borne herbicide damage can be, if it drifts onto a plant, you might see damage just on one side of the plant. Herbicide damage usually happens very quickly. It wasn't there yesterday, and it is there today. Now, a lot of times people think that tree issues just all of a sudden happened, but usually they're happening over time. We just didn't happen to walk by the tree in the past couple of weeks to see it. But herbicide damage is definitely a quick onset thing. It might be localized, like I said, on one side of the tree and not on the others. Or you might see similar damage on a wide variety of plants in the area. So you might see it on a redbud, you might see it on a tomato plant, you might see it on a holly, just very a wide variety of unrelated plants showing the same symptoms. That's usually a sign of herbicide damage. Herbicides can also enter into tree roots if they've been applied to a lawn. Most of the lawn herbicides that we're going to use are going to affect broad-leaved plants. Many of our trees, like this redbud, are broadleaf plants, and the roots of trees can extend well beyond the drip line of the tree and into lawn areas. So we can see herbicide damage from lawn treatments and not just windblown. Weather is also one of our big causes of abiotic disorder. And in addition to wilting and leaf drop, drought will cause death within, it'll cause tissue death within the trees. So here we can see some drought scorching at the ends of the leaves. In severe droughts, like the drought that we had in 2016, the leaves will actually shrink in size. They'll become smaller. They're trying to minimize their exposure to the sun. The trees will shut down parts of the root systems because there's just not enough moisture in the soil to take up water or for them to take it up. So they'll shut down and try to minimize the need for water by reducing their size. The chemical processes within a tree will actually change, and these will be long-lasting responses to that drought. So, after 2016, we saw continuing issues in 2017 and 2018. And these changes can also initiate that death spiral or that tree decline spiral. Trees die very slowly over many, many years. So, what happened in 2016, we might not actually see the death until 2019, 2020, but it's all related back to that severe drought stress. Excess soil wetness can also cause problems that can cause root suffocation because there's not the wet soil doesn't have enough oxygen in it to give oxygen to the roots. And it can also open the door, maybe it doesn't kill the roots outright, but that wetness can create the conditions for those fungal diseases that cause root rots. During unusually rainy years, a persistent overcast, a lack of sunshine, can interfere with photosynthesis and cause disorder symptoms in trees, like larger leaves, where they're trying to expand their surface area to catch more sunlight. Leaves that appear pale or yellow, that condition is called chlorosis. And the end result is a deficiency in the carbohydrate stores in those root systems. So we'll see some declining health in the trees. Their ability to overwinter can be compromised, and they might not have enough carbohydrates stored in their root system, from the photosynthesis that they normally get through the year. They're going to store that energy in the root system, and that's what's going to give them the energy to push out new buds, new flowers, new leaves in the spring. If they don't have enough of that, then we might see fewer leaves being pushed out, and just general weakness in the springtime. Freezing and heat can both also cause this leaf scorch type here. And this photo down here, this was an ice storm just a few years ago. These were taken down at Central Park in Cumming. These trees were coated with ice. And the weight of the ice, these are younger trees, caused them to bend over. You can still see some ice up here. But the weight caused these trees to bow over because they were still flexible enough to do that. And it stayed long enough that there was no recovery. There was a permanent deformed growth pattern because the trees did not spring back up. The weight was on there long enough to bend them permanently. So eventually these trees were cut down. In older pine trees, the weight can bend over just the tops with enough weight to actually snap them off. I remember hearing the trees snap off in a severe ice storm when I was a kid. It sounded like there were explosions happening all around the house. It's pretty scary. Girdling is another abiotic disorder, and this gets into what I call operator error. So if we look at this tree down at the top picture, the root is actually wrapped around the tree. And so what's happening is it's cutting off, or it's causing girdling around the base of the tree. That's it's basically cutting off the flow of nutrients from the roots, flow of water from the root system up to the top of the tree, and the carbohydrates flowing down through the root system. The cambium of the tree is the living tissue, and it's like 1 or 2 cells deep, thick, right under the bark. So anything that causes damage to the bark area is also going to damage the cambium and shut off all of the flow of water and nutrients in that area of the tree. So that's what the root is causing it here. Up here, somebody has tied a rope around the branch of this tree, and you can see how the branch is trying to come out and grow over that. But this girdling is cutting off the flow of nutrients to that branch, and eventually that branch is going to be dropped off, because if it can't get any nutrients, it's going to die. Other things that can cause that, plant labels, if you plant something and leave the tag on it that identifies it, eventually the branch that it's on is going to grow bigger than the girth of the tag that's on there. Insects and wildlife can also cause girdling. There are some insects that will girdle, they'll eat the bark off around the stem of a plant. Wasps will do this. The paper wasps will come into a tree. Actually, I had a client bring me some photos of a holly bush that was dying back in places. And when we got down and looked at the branches of it, the wasps had actually come in and removed big sections of the bark from around the branches and twigs to take in and make their nests. So they can girdle the plants. Wildlife, things will, especially on young trees, gnaw around the bark at the base of it and cause girdling issues there. Soil issues, compaction, nutrient deficiencies, improper pH, all of these will cause problems with the tree. This is a construction zone. This is actually over when Beaver Toyota was being constructed. This is some views from their parking lot. So if you look at this soil around here, it is hard. But compacted soil isn't just hard, it's also lacking in pore space below the down in the root zone. And that pore space is important for holding moisture and oxygen for the tree roots. So this very hard soil is not going to be holding, or this very compacted soil is not, all of those pore spaces have been squished flat. So there's no room in there for moisture or for oxygen. The water kind of just washes down off of this. And that hard soil doesn't leave any space for those very slender, tender roots to grow. So this poor little pine tree is not only in compacted soil, but we've got this huge mulch volcano around it. So what that's doing is adding to the oxygen deficiency, because the oxygen has to get through another 3 feet of matter here to get to the roots. And it's holding moisture against the trunk of the tree, which is going to cause the bark around the tree to rot, which is also going to be another way that girdling happens. We've got all of this heavy stuff on the soil as well. So construction zones can be really hard on trees. Here's another example of that. We've got some looks like we've got some erosion issues going on around this tree. So the roots are exposed. Now, some trees do naturally bring their roots up to the soil surface. but that opens us up to, other issues, like if they're in the lawn area, they're going to be run over by the lawn mower and damaged that way. Land disturbance. Here we've got some road expansion going on. So we've got some disturbance of the land in root zone areas. And you can see at the top of this bigger tree, we've got some defoliation going on. And that's one of the symptoms of root injury, root damage. You might see that dieback all around, or if the root's just been damaged on one side, you might only see, so these roots would be feeding this outer trunk of this multi-stem tree. So you might only see dieback on one part of the tree. If the roots have been cut on one side of the tree, you might only see defoliation on that side of the tree, but eventually you'll see branches that will die back and drop off. Because if they're not helping support the tree will shut them off and drop them down. We can have mechanical damage. This girdling down here in this tree was caused by a string trimmer, because we don't have a mulch island around this tree to protect it. So the lawn mower and the string trimmer are coming right up to the tree, banging into it and girdling it every time they come and cut the grass. Here we've got a tree in, this is over in Chattahoochee River Club. They've got these beautiful, huge oak trees lining the streets, but they're in very constricted areas. And it looks like somebody probably maybe ran into this at some point and caused this bark damage here that hasn't fully healed. So we can cause injury to the trees and trauma as well. Planting mistakes, the wrong place for the plant. So a lot of times we'll choose trees without having an adequate knowledge of the environment that they actually need. That's why we might see dogwoods, which are small understory trees that need shade, being planted in the middle of a lawn. And then they are under a lot of light stress and heat stress, and they'll respond by drooping their leaves down. So they look like they might be wilting from not having enough water, but they're actually trying to minimize their leaf exposure to the sun, because they're not supposed to be exposed to that much sun. They actually need the shade of other trees. They thrive in that part shade or dappled shade environment. So they'll droop their leaves down and try to minimize their exposure. And then the homeowner or the landowner will look and say, oh gosh, that tree is wilting. It must not be getting enough water. So they'll start adding water to it, which creates the wet soil, which is another abiotic disorder that can cause trouble. Planting too deeply. So this plant is an example of one that has been planted too deeply. You can't see the root flare. So if you can't, normally the tree's going to come down and then flare out right here. You should be able to see the root flare if it's planted properly. If it's planted too deeply, again, the roots are going to be farther below the soil than they should be, and that's going to be limiting the oxygen availability to those roots. Trees that are planted too closely together, like a lot of our Leland cypress screening plants that we see, they're going to be competing with each other for root space, for water, for soil nutrients. They're going to be rubbing against each other and damaging each other's branches, shading each other out, just creating all kinds of stress issues. And trees also that are planted too close or in close proximity to structures like house foundations, sidewalks, they're gonna suffer from a pH change, possibly having a soil pH that's too high, because the lime that leaches out of those concrete structures is going to raise the pH in the soil as well. Environmental stress is another cause of abiotic disorders. Again, this tree has very, very restricted root zone. It's planted right at the edge of the street. and up against a concrete sidewalk. What do you think the soil is like underneath that street? It's going to be extremely compacted to support the structure of the road. There's not going to be a whole lot of water infiltration for the root zone of this tree. We've got some up here from the lawn. But we're going to have some severe compaction issues with this soil, a limit of water access. As the roots grow, they might begin lifting the concrete of the sidewalk or lifting the street. And that was the case in other parts of this neighborhood as well. Down here, we've got these trees that are very compacted, in very small root zone areas. We're also going to be having heat feedback from this sidewalk. As it absorbs the heat of the sun, it's going to be throwing it back on those trees, which can cause stress. Street lights are going to be an issue as well, because one of the things that helps a plant get ready for winter is the reduction in daylight hours. In addition to temperature changes, the day length gets shorter in the fall, and that's a signal to trees, hey, we need to start slowing down our growth, we need to start hardening off and getting ready for winter. Well, trees that are right under a street light are continually exposed to light, so it messes up that signaling system. So they might not be going into dormancy as early as they need to be. They might still have young, tender leaves budding out because they think it's still spring because they've still got all this light. And then we get a frost or a hard freeze, and that can cause damage to those leaf tissues, which can even, go in through the tree to the branches and down to the trunk and cause some severe winter injury. Over here, again, we've got these little tiny crepe myrtles, but they're going to grow. This is a new planting in this tiny strip of land between driveway and sidewalk. And we're going to talk about this next week when we talk about selecting trees for urban landscapes. But this is probably in compliance with the tree ordinance of the county. But that's not necessarily a good environment for a tree. There's just not enough land mass there for it. Another abiotic disorder is age. Just like all of us, humans and other living organisms, we have defined lifespans. So for some trees, like oaks, it can be 200 to 300 years in their appropriate planting conditions. For a Leland cypress, it's going to be about 20 years. And when we put those trees into an urban setting, we're going to reduce that lifespan. Faster growing trees like the Leland cypress naturally have shorter lifespans because they're going to zoom up and hit their maturity point, and then they're going to go into the decline of age. Like I said, urban trees have shorter lifespans because of all the stresses that they face environmentally. So the mean lifespan of an urban tree is 19 to 28 years. The half-life of that is 13 to 20 years, and that's the point at which you need to start replacing the trees in the landscape, because at that point, about half of the trees are going to be dead. Tree issues can be multiple. They can have more than one condition going on at a time. So in the summer or in the early spring, they might have a fungal issue along with an insect issue, along with a nutrient deficiency issue. And it's not always easy to untangle which one came first, which one has the most effect. But once we start having multiple disorders, then we're going to increase stress factors and we're going to increase tree decline. Correcting the underlying issues that are causing that problem, that disease, that disorder, that stress, those are going to be crucial to mitigating the symptoms and restoring health. But it's important to remember that lifespan And it's also important to remember that once a tree enters decline, our ability to reverse that is going to be seriously limited. It's a natural process from life to maturity to decline to death. We can do mitigation efforts to try and reduce the stresses, correct the problems, and maybe delay the death, but death is natural. It is what happens with trees. Eventually, it does happen. So trees die slowly, as I mentioned, over a span of years. There's usually not going to be sudden death unless there is some kind of injury to the tree. There are numerous signs of tree decline: dieback, defoliation, abnormal leaf size or color, dead and falling branches. And this is a big one. If you see mushrooms growing along the root line or on the trunks of the tree, that tree's already dead. It just doesn't know it. And you need to call somebody out and have it taken down before it falls down, because that's what's going to happen. It will fall down. This tree is dead and there's no bringing it back. There's a great publication out there by some of our UGA agents called "Is My Tree Dying?" And this photograph is actually taken from that publication. This is a definite sign that that tree is dying. So have it taken down before it causes property damage or falls on somebody. Okay, now we got another chance for questions here.